Hello, and today we are going to be solving Leetcode 54 spiral matrix. So basically, you've been given a matrix and you've been asked to print out the numbers in each cell in a spiral order. In this one, we go 1, 2, 3, 6, 9, 8, 7, 4, 5. So the approach is basically, let me try and represent this right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Few things that I want to point out is index wise, if you're moving from here to here, it's increasing, right? And index wise, if you're moving from here to here, the index on the rows is increasing as well, right? However, if you're moving from here to here, index wise, you're moving from the end, so it's decreasing. And if you're moving from here to here, it's also increasing, right? So we can say this is, so index wise, right? Just for the, we know that this is the left. You can call this the left and call this the right. At the same time, this is also the top, and here is the bottom, right? This is the bottom as well. Now, here we are asked to print it in this way. Moving here, moving here, moving here, get here, and then we move here. What we can clearly see is we are moving in this direction, which is increasing in index order, moving down, also increasing, then decreasing, and then increasing. But we can also see that we are moving from top left to top right, right? And then from top right to bottom, right? And then from there we move from bottom right to bottom left, and then from bottom left to top left. That is exactly what's happening here. Top left to top right to bottom right, bottom right to bottom left, and so on and so forth, right? So basically that is all we need. We just have to make sure that we are within bounds. And also, anytime, for example, if after we move from top left to top right, top now moves one step down, so top is going to increase by 1, right? Anytime we read from top right to bottom right, this part goes away, and right moves in this direction, which is going to be negative, so right is going to decrease by 1. From here we move from bottom left to top left. After we read this out, or we print this out, bottom is going to come up 1 step, and that is going to be a negative, so bottom is going to decrease by 1, right? Those are the few things you need to do, and also make sure that you are within bounds of this. So let's go and see how we can represent that in code. So let's get rows is equal to the length of matrix, and then we get columns is the length of matrix columns. Now the left starts at 0, so is the top. right? And then the right, which we have determined is the length of the row, right? 0, 1, 2, 3 at this time is the length of the row. So index wise is -1, right? So right is, or actually columns, right, -1 is the length of columns, right? And then bottom is rows -1. So our results is going to be stored in an array. Let's come down here and say, while the length of our results is less than the length of everything in this array, which is this by this, row by column, right? So rows times column. So what we are going to do is move from top left to top right. Right, so for call in range left to right, again in range the end is non-inclusive, that's why I added +1. Res dot append matrix left, top, because the role is going to remain the same while we are just counting this, right? And then the columns are going to be variable. After we have read the top now increases by 1 because we have read everything here, so now top down comes down here. So the next thing we are going to do is top right to bottom right. For row in range right top to bottom, right? We append the following. We append the rows and then the rights. And now that we've done that, the right decreases by 1, right? So that is that part. Now before we read the down part of it, we just have to make sure that the down, the bottom part is not equal to the top part, because that's where when we actually stop counting, right? So long as if top is less than or equal to bottom for row in range starting from right to left -1, and we are also coming backwards, right? So for that results, we append the following numbers. So here, right, bottom remains bottom, but the columns are going to change. Oh, we are reading this. So for columns, so bottom and then columns. Okay. Now, bottom is going to decrease by 1. And if left is less or equal to right, practically going to do the same thing, right? So if the left is not equal to right, you're going to start moving up here, right? And oh, okay, so what we are doing, so what we did here, let me make sure I write that, is bottom right to bottom left, right? And what we are doing here is bottom left to top right, top left. All right. So for row in range, starting from the bottom, going to the top, you're going to the top, we are starting from down here and going up, right? So for this one, we do what are we going to do here? We append the matrix, the row, and then left. Now left is going to increase by 1. Left, if it goes here 1, after we read here, now left moves here, right? After that we return results. So hopefully I have said everything and I have done everything right, said and done everything right, and this is going to be perfect. So let's run it and see. Uh-oh, I missed something. So let's go back and walk through the code. Now the rows, this is rows, columns, top is like that, right? It's the length of columns minus 1, the row bottom is the length of rows minus 1. So from top left to top right, we are moving from left to right. So we add top and then a column and then top, I missed an equal to here. Maybe that's it. I don't see myself, so let me try again. All right, awesome. So that is how you solve a spiral matrix. All right. Thank you for watching. See you in the next one.